Thank you everyone for joining us today for our webinar, Reducing Risk, an Introduction to Survey Data Anonymization. Just letting everyone know, as you may have noticed, you will be automatically muted when you enter the room. This webinar is being recorded and the chat may be archived for those who are unable to attend. We encourage everyone to use the latest version of Zoom so that you have access to all of the features. Please use the chat feature if you are having technical difficulties or if you have additional resources to share. Please use the Q&A option to ask questions of our presenter. Questions will be addressed at the end. You may also raise your hand if you wish to ask your question out loud. Questions may be asked in English or French. We abide by the CARL Code of Conduct, and you can find the complete Code of Conduct online. CARL is committed to providing a welcoming, safe, and harassment-free environment for its staff, membership, committees, and working groups, as well as for participants, speakers, and organizers of CARL meetings and events. We do not tolerate harassment of any kind. Our presenter today is Kristi Thompson. Kristi Thompson has been the Research Data Management Librarian at Western University since 2019, and previously held positions as Data Librarian at the University of Windsor and as a data specialist at Princeton University. Her involvement with Portage includes participation on the Federated Research Data Repository and Dataverse North working groups. She has a computer science background and has published on topics ranging from international data sources to Aboriginal sports practices. And I'm going to hand things over to Kristi now.
Okay, hi everyone, and thank you for joining this webinar. This is Kristi Thompson. I'm going to be talking about data anonymization, specifically about methods for assessing the anonymization of survey data. The field of survey data anonymization is pretty large and complex, and many very technical articles have been written about it, mostly by and for computer scientists. What I'm hoping to do in this webinar is to distill some of that information down to some essential concepts and provide a more accessible and practical introduction to data anonymization and risk assessment. Note that I am specifically focusing on survey data. Qualitative imaging and other types of human subjects data have completely different issues that I won't be touching on. I'm going to start by giving you some background in basic data anonymization concepts, and also a bit of information on the practical reason why I started learning about data anonymization in the first place. I first became seriously involved with data anonymization due to a project to rescue some data files that were at risk of being lost. The project began with a bunch of survey files from Health Canada released on Canada's Open Data Portal as a result of an open government mandate a few years ago. The surveys were published as CSV files without any code for reading them into statistical software, without any value or variable labels, and in some cases without codebooks or questionnaires. Basically, they were a complete unusable mess. A group of data library people from Ontario, including me, got together and worked to track down documentation and create cleaner and more user-friendly versions of some of these data sets. Now, the data released without documentation were bad enough, but during this process, we also discovered on the same open data portal documentation for additional data sets without data. And we had the bright idea of reaching out to Health Canada to ask if they had data from these additional surveys anywhere and if they'd be willing to share it. I eventually got in touch with a helpful person who dug up some files that were still hanging around in obscure folders on some hard drive in somebody's office. And she sent them to me. And oh dear. Some of them had not been anonymized at all. The files had census geography, postal codes, telephone area codes, you name it. These included some pretty sensitive surveys too. There was one relating to HIV that asked questions about sexual behaviors, and another series with questions on illegal drug use. Now, we could have just thrown the data files away, but these were, as far as we knew, the only surviving data from some really interesting and important public surveys. And after some back and forth, we realized that Health Canada just didn't seem to have any idea what to do with them. So that brought about phase 2 of the data rescue project. And I'd like to give a shout out here to Alexandra Cooper, who worked with me on some of the data that I'm going to be talking about. Our first and obvious step before we did anything else was to delete the direct identifiers that were present on these data sets and just get rid of them completely. Direct identifiers are any information collected by the researcher that place study participants at immediate risk of being re-identified. Direct identifiers include things like names, phone numbers, social insurance numbers, student numbers, and so on. You can probably think of others. The definition of direct identifiers is actually a bit more expansive than you might expect, particularly when it comes to geography. Any geography containing less than 20,000 people is often considered a direct identifier. Exact dates linked to individuals, such as birth dates or dates of medical procedures, are also widely considered personal identifiers. The U.S. Health Insurance Portability and Accountability Act has a list of 18 personal identifiers that is frequently referred to in the literature. Well, a more recent set of guidelines from the British Medical Journal includes a list of 28 direct identifiers based on multiple international guidelines. I'm not aware of a Canadian list. If you're looking for a list, then I like the British Medical Journal one that I've linked here. Identifying and removing or masking direct identifiers is always the first step in de-identifying data. However, this is not enough to ensure that data has been fully anonymized. Survey and health data sets generally also contain many other details about respondents, such as age or marital status, that aren't directly identifying on their own. These variables are called quasi-identifiers and also need to be considered. Quasi-identifiers are characteristics relating to individuals that could be linked with other data sources to violate the confidentiality of individuals. Some variables may be used in combination to derive quasi-identifiers. For example, community size, at first glance not particularly identifying, could be combined with a broader geographic grouping to infer a location more precisely. Quasi-identifiers are commonly thought of as being demographic and socioeconomic variables that have the potential to be linked with other data sources to violate people's confidentiality, or to be recognized by a person acquainted with the survey respondent. Specific common examples include age, gender identity, income, occupation, industry or place of work, geography, ethnic and immigration variables, and so on. Other potential quasi-identifiers could include characteristics like membership in specific organizations or use of specific services. So it's not possible to come up with a single comprehensive list of all possible quasi-identifiers. Variables that relate to geography in any way need to be treated with extreme caution. Potential hidden geographic identifiers can include features like presence of a university, hospital, or international airport in a respondent's community. For example, a variable giving the distance to the nearest emergency department in a health survey. These variables need to be considered alongside any contextual information about the data set. For example, is it clear from external information that the participants in this study lived in a particular area or type of community? I once worked with a graduate student who demonstrated as part of an exercise that information like the distance to drive to a city with certain resources could be combined with information indicating that a respondent might live on a reservation to pinpoint some respondents' locations to very small communities. If you're concerned about privacy, geographic information systems can be scary. Computer science students can be scary too. A couple of technical definitions. Risk is created when variables can isolate individuals in a data set, and the identifying information in these variables can be matched to persistent information that an attacker may reasonably have access to. A set of records that has the same values in all quasi-identifiers is called an equivalence class. An equivalence class of 1 corresponds to an individual who is unique in the data set on some combination of characteristics. Such a person may be at risk of being identified. This person is called a sample unique. If your survey is a complete sample of some population, this person is also a population unique. Surveys also contain lots of non-identifying information. Usually most questionnaire responses are non-identifying: opinions, ratings, anything measured with Likert scales. Temporary measures such as resting heart rate, number of times someone ate breakfast last week. Free-text responses also may be non-identifying. They need to be considered on a case-by-case basis. Something like, the library needs better Wi-Fi, is not identifying. However, a comment that included information about a specific event, like, and when I spoke to my colleagues at the plant about organizing a union, that's a possibly identifying statement. So now you know what quasi-identifiers are, and that they can be used to potentially narrow down the identity of respondents to a survey. So what do you do about them? Well, I mean, technically, you could, of course, just delete or mask them the same as you do with direct identifiers, but doing so would seriously impact the ability of future researchers to make use of a data set. What is needed is some way of assessing the quasi-identifiers to determine how much risk they contain. This process is called statistical disclosure risk assessment. A technique called k-anonymity is the leading way of doing this formally. As a first pass, there are some common sense rules of thumb you can use to assess the quasi-identifiers in a data set. Quasi-identifying variables containing groups with small numbers of respondents, for example, a religion variable with 6 individual responses of Buddhism, pose high risk. Extreme values, such as more than 10 children or having a very high income, also pose high risk. The size of identifiable groups both in the survey and in the general population need to be considered. There may only be one person from Winnipeg in your random digit cell phone user survey, but if your survey doesn't narrow it down any further than that, that person is pretty safe. Contextual information that accompanies the data also needs to be part of the analysis. If it is clear from the context of your research that all of your interview subjects worked at tool and die plants in Oshawa, that narrows things down quite a bit. Look at the demographic variables in the data set that you're working with, and consider describing an individual to a friend using only the values of those variables. Is there any likelihood that the person would be recognizable? I'm thinking of a person living in Toronto who is female, married, has a university degree, is between the age of 40 and 55, and has an income of between $60,000 and $75,000. Guess who that person is? Even if there is only one such person in the data set, this is probably not enough information to create risk, unless contextual information about the data set narrows things down further. Let's say you know that this is a survey of volunteer hockey referees. You also need to think about variables in combination. An age group variable and a marital status variable might not seem particularly identifying either in isolation or in combination. But what if you have a case where an under 16 respondent said they were married? This is an example of a hidden extreme value. Common sense can only take you so far once you realize that unusual cases can arise as a result of unusual combinations of otherwise non-risky variables. K-anonymity is a mathematical approach to demonstrating that a data set has been anonymized. It was first proposed by computer scientists in 1998 and has formed the basis of formal data anonymization efforts since then. The basic concept is that it should not be possible to isolate fewer than k individual cases in a data set based on any combination of identifying variables. That is, a record cannot be distinguished from k-1 other records in its equivalence class. K is a number set by the researcher. 3 and 5 are both commonly used. In practice, I've never seen a value higher than 5 referenced, and that's the number most commonly referred to in the literature. Why 5? I don't know. An example may help illustrate this concept. Imagine your survey, let's say of workers at a tool and die factory in Oshawa, has 3 demographic variables: age group, gender, and ethnic group. If an individual in the data set is not a visible minority, is a male, it is between 25 and 30, then for the data to have k-anonymity with k equals 5, there must be at least 4 other individuals in the data set with the same set of characteristics. And this must also be true for every other individual in the data set. Each person must have at least 4 data twins. Even if, in this example, cases 1, 6, and 13 form an equivalence class with k equals 3. Each case in the equivalence class has 2 data twins. Even if an attacker knew that an individual was in the data set and was able to match their characteristics against the data, they would not be able to tell which of the 3 cases was the target individual. Case 14 in this sample has no data twins. It is a sample unique. A data set's k is the size of the smallest equivalence class in the data set. So in this case, the data set's k is 1. In order to achieve k-anonymity with a k of at least 5 in a data set, you use what are called data reduction techniques, including global data reduction and local suppression. Global data reduction includes things like grouping variables and responses into categories, for example, age into 10-year increments, and for already categorical variables, merging them into larger groups. In extreme cases, global data reduction can include the complete removal of risky variables from the data set, for example, all direct identifiers. Local suppression means deleting individual cases or responses. For example, a member of the under 16 age group who responded that they had a university degree or were married might have the response to that question deleted as an alternative to further recoding the otherwise non-risky variables of age group or marital status or education, or whatever the risky response was. By looking at frequencies and creating bivariate tables of variables, it is possible to single out the obviously risky categories on variables and regroup or suppress them as a prelude to checking k-anonymity. It is relatively easy to check k-anonymity using standard statistical software, even though most packages don't have built-in functions for doing so. Here I'm showing simple code I've used for checking k-anonymity in 2 widely used packages, Stata and R, and providing a link to the somewhat more complex code for doing it in SPSS. There are also various free software packages you can download that will do this, but feel free to borrow my code. So, k-anonymity is a relatively simple and widely used technique for assessing a data set for anonymity. Unfortunately, it is not a perfect one. Some fundamental flaws with the k-anonymity concept were discovered and published within a few years of it being first described. K-anonymity is intended to be a form of guaranteed data anonymization, and that is how it's often described. It guarantees that every record in the anonymized data will be indistinguishable from k-1 other records in the same data set on some combination of variables. However, survey respondents are not generally told that no one will know which line of the data file holds their survey responses. They are told that their answers to survey questions will be kept confidential. Let's return to the workplace data set. In this case, example, cases 1, 6, and 13 still form an equivalence class with k equals 3. So even if you know which people in this survey population match these characteristics, you can't tell which person matches which case. But these 3 people all answered a particular question about whether their workplace should unionize the same way. You now know how all 3 of them answered this question. If your friend or employee Fred is in this survey, you don't know if Fred is a person 1, 6, or 13, but you do know how he answered the question on joining a union. Fred's confidentiality has been violated. Extensions of k-anonymity, such as p-anonymity and L-diversity, have been developed in an effort to deal with the attribute disclosure issue. However, as one set of authors noted in a review of k-anonymity and its variants, neither k-anonymity nor its enhancements are entirely successful in ensuring that no privacy leakage occurs while keeping a reasonable data utility level. A brief explanation of one of the variants of L-diversity will help illustrate this problem. A data set is said to satisfy distinct L-diversity if, for each group of records sharing a combination of demographic attributes, an an equivalence class, there are at least L different values for each confidential variable. In our example workplace dataset, every single group of data twins would need to include both yes and no responses to the union question, since 2 would be the maximum possible value of L for this question. And this would have to be true for some value of L for every confidential answer in the dataset. Now imagine a typical survey dataset with dozens of questions, each of which needs to be considered for L diversity for each equivalence class. Basically, the issue with techniques like L diversity is that they are only possible to implement in datasets with very few variables. For large datasets, implementing them would be far too time-consuming to do by hand, and there just aren't good ways of doing this automatically without completely messing up correlations in the data. For some of the more esoteric methods, so no theoretical automatic implementations have even been described in the computer science literature. One of my favorite articles on the topic actually flat out admitted that they couldn't see any way to practically implementing the privacy-preserving framework they had come up with, but they felt the need to publish it anyway, presumably just to frustrate people like me. Even if techniques like this could be implemented, in most cases, achieving anything like L diversity or T closeness or P diversity would completely destroy the reanalysis value of the data set, making going to this level of effort to make data shareable rather pointless. However, all is not lost when it comes to ethically sharing research data where respondents were promised confidentiality. What I haven't discussed so far is the role of sampling. Until now, I've been speaking as if it was possible to have perfect knowledge of a survey population, and as if it were a complete sample of that population. Let's return to that workplace survey data set, but this time imagine that the data set is only a 50% sample of the population. In this example, cases 1, 6, and 13 still form an equivalence class, but the equivalence class has 5 additional members who are not in the data set, and their views on forming a union are unknown. So, assuming that an observer has no way of knowing whether a particular individual is in the published data, being in this equivalence class no longer definitively reveals anyone's opinions. Sampling creates uncertainty that any given individual is in the data set at all. A sample unique may not be a population unique, although this still may be a concern. But basically, if an equivalence class in the dataset can be assumed to have co-equivalents, data twins, outside the dataset, whose opinions or attributes are unknown, then attributes are not disclosed by membership in an equivalence class. This is a reasonable assumption in cases where k-anonymity is met for k of greater than or equal to 5, and where the dataset sample is a small subset of the population it is drawn from. I don't have a precise definition of small, but I would assume that less than 5% is probably reasonable, and many large survey datasets are far less than that. So attribute disclosure, in the absence of identity disclosure, ceases to be a concern in the case of a sample that is a small percentage of a large population. I'll show you an example of this later. There actually are other strategies for preserving privacy and data that don't involve k-anonymity, and I want to describe them here because you may come across them if you're looking at the general anonymity literature. These strategies basically involve increasing the amount of randomness there is in the data. I don't recommend them for most users. The first is perturbation or random noise, which is adding or subtracting a random number following some distribution from numeric variables. This maintains the overall distribution of the data, but changes the error term in the data in a way that is opaque to the researcher, basically possibly messing up analysis. It can make it harder to find significant results, which is not something that tends to make researchers happy. This technique is also not suitable for categorical variables. The other big one that is used for categorical variables is value substitution, which means taking a variable from one record and exchanging it with that of another record. This maintains the univariate distribution of values in the data set, but can introduce other errors and may change bivariate or multivariate distributions. Some statisticians love these things, or at least love talking about these things, but they have not gained traction among most researchers in general. Doing them in a sensibly data utility preserving way is complicated and may require that the data analyst be able to compensate for bias and distortion in the resulting data set, which is why analysts tend not to be very happy about these things. I mentioned at the beginning of this webinar a data rescue project that led to me trying to teach myself all about data anonymization. I'm going to be discussing one of the data sets a little more, so you can see how some of these techniques work out in practice. One of the data collections I found myself working with was the National Anti-Drug Strategy Survey Series, a set of surveys of adolescents aged 13 to 15, which asked them questions about their drug use. The first data set in the series had 1,502 respondents and 339 variables. The demographics of concern were quite limited, thankfully, once we have removed the direct identifiers that we weren't going to keep in any case. This may have been partly due to the age of the respondents. Marital status wasn't a concern. They didn't ask about employment, and income was represented by a question about allowances, which we decided wasn't really an identifying variable. We ended up looking at 5 quasi-identifier variables of particular concern: age, which had 3 categories, sex, which had 2, geographic region, which was based on province and had 7, visible minority status, which had 2 categories, and aboriginal status, which had 2 categories. Simple multiplication will show that these 5 variables could produce 126 possible equivalence classes. Well, actually, arithmetic would suggest 168 equivalence classes. It was 126 because visible minority status and aboriginal status are non-overlapping as defined. Ask Statistics Canada why. That's a rather complicated question, but this is what we were working with, 126 equivalence classes. If these were distributed equally across the data set, we would expect each equivalence class to contain about 12 cases. However, for most real-world variables, some groups will be much larger than others. In practice, we had 21 equivalence classes with only a single member, and a total of 42 equivalence classes with less than 5 members. K-anonymity is hard. We were only looking at 5 quasi-identifier variables with only a few categories in each, in a fairly large data set. We were not able to produce a data set that satisfied K-anonymity, let alone any more stringent criteria, while retaining those 5 variables. We were able to achieve K-anonymity by deleting the region variable. On the remaining 4 variables, there were no equivalence classes smaller than 5. K-anonymity is difficult to achieve in practice, and the difficulty increases as the number of quasi-identifying variables increases and the number of cases in the data set decreases. I can confidently state that the only way to produce a version of this data set that satisfied even the simplest version of L diversity would have been to delete all the demographic variables. But how risky would it have actually been to retain the region variable? For our sample unique cases, those 21 equivalence classes with only a single member, also population uniques. Being me, I decided to check this. I was interested in exactly what role sampling would play. I downloaded a Census of Canada public use file, subset it, and manipulated the variables and weighted the file to produce a data set that matched my survey population exactly, but represented the population aged 13 to 15 in Canada at that time as a whole. In effect, I created an artificial census of the population my survey was drawn from. In the census data set, the smallest equivalence class was estimated to have 370 cases, with the next smallest containing 518 and the remaining 214 equivalence classes being considerably larger. That is, each sample unique in the drug use survey was estimated to have a minimum of 369 data twins in the general population. K-anonymity in this case overestimated the re-identification risk by a factor of 370. Given the sensitivity of this survey, removing the region variable probably made some sense, but leaving it in would have been defensible given that I checked population risk using the census. Most data curators, however, are not going to go to the effort of using the census to check population risk, and results will not always be as dramatic as the ones in this example. This really was a relatively small percentage of the sample of 13 to 15-year-olds in Canada as a whole at the time. Most of the literature on data anonymization neglects the massive effect that sampling has on reducing risk. Anonymization software also tends to completely ignore this factor. In practice for the data curator, it makes sense to look at k-anonymity as a way of safeguarding identity disclosure in sensitive data while relying on the sampling effect to deal with attribute disclosure in the case of a small sample drawn from a large population. However, complete or near complete samples of smaller defined populations, for example, a survey of a single workplace or the people who are attending a particular program, are inherently much riskier in a way that can't completely be compensated for using k-anonymity. And the curator may want to consider options for sharing that do not involve public release of even anonymized data. Checking k-anonymity is not difficult using standard software. To de-identify a data using common statistical software, I would use the following steps. First, identify and remove or mask all direct identifiers and identify the quasi-identifiers of concern. Use frequencies and bivariate tables to identify small groups and iteratively create larger groupings using data reduction. Check k-anonymity using the code I provided or another technique, and inspect small equivalence classes. At this point, you can use the common sense approach to determine if these are truly risky. Where uncertain, regroup variables or suppress individual cases. This is probably adequate for a data set that is a small sample and is not inherently high risk. For example, does not ask about things like illegal activities. For inherently higher risk data, again, you may want to consider other methods of sharing. But wouldn't it be nice to have an easier way to de-identify a data set? Way to automate it? While working on the initial de-identification project, and later while contributing to some documents for a working group, I tested 6 different anonymization packages that I found recommended on various online lists. To be blunt, I think that these lists have been come up with by people who never actually tried any of the packages on them, since they included things like a set of incomplete Java routines and an almost completely undocumented thesis project. After the first couple I tested, I was counting it a win if I could actually get the package to load data. The 2 that seemed the most functional, although still with some shortcomings, particularly in documentation, were SDCMicro, which is an R package with an add-on graphical interface, and Amnesia. Both of these software packages will check for k-anonymity given a list of quasi-identifiers, and they also provide tools for dealing with direct identifiers. Of the 2, I preferred SDCMicro for usability and because it correctly handled missing data. Amnesia doesn't allow for missing value specification, but both have similar approaches to automatically adjusting quasi-identifiers. By missing values, what I mean is that someone who did not answer whether they are married or not is not in the same category of risk as someone who is belongs to a particularly unusual category of response to that question. And as Amnesia treated a small group of people who did not answer a question as an equally risky group as people who are of an actual small category. These tools take a hierarchy approach to automatically de-identifying data with quasi-identifiers. This basically means that the user needs to predefine possible generalizations for the quasi-identifiers in the dataset, and the program will search for possible solutions and recommend a set of generalizations to use. For datasets with a large number of quasi-identifiers that you think still may somehow be de-identifiable, or cases where several datasets with similar quasi-identifiers need to be de-identified, this might be a useful approach. In the data I have worked with, I found it easier to do by hand. To help you visualize what I'm talking about, here's a possible hierarchy for the variable marital status. The user needs to predefine a hierarchy like this for every potential quasi-identifier in the dataset to fully make use of these anonymization tools. Some final observations. Guaranteeing that data has been completely anonymized is difficult, and the difficulty increases exponentially with the number of potentially identifying variables present. A common standard for assuring anonymity is k-anonymity, which can be calculated easily using standard statistical software. Actually achieving k-anonymity can require a great deal of data modification or suppression, though the role of sampling somewhat mitigates against this. Finally, a way of doing this automatically would be very nice. Software aimed at the general academic survey researcher should not assume special knowledge in the field of data de-identification. Given this, I didn't find any packages I would unreservedly recommend out of the 6 packages I tried. I'm dubious that any software could ever make this process exactly simple, although I do think that properly documented software could potentially help a great deal. And finally, a few suggestions for further reading if you want to know more about these topics.
Thank you very much, Kristi. Does anyone have questions for Kristi? You can either use the Q&A tool, or you can also raise your hand and you can ask them out loud. See that we have, oh, someone did have a question, but then lowered their hand. Again, if you have questions, you can raise your hand and I can allow you to speak, or you can place it in the Q&A tool. We do have a question from Lucia. Are any of these tools used by Stats Canada?
That's a very interesting question. When I first became involved with this with the Data Rescue Project, I actually reached out to a contact at Statistics Canada and asked them what tools they use for de-identification. The answer I got back was that Statistics Canada's methods for de-identifying data are confidential, so they would not answer that question.
Thanks, Kristi. We have another question now from Joyce. Joyce, I've given you permission to speak, so you can ask Kristi your question.
Great, thanks. You can hear me?
Yes, I can.
Okay, great. Thanks very much for this. It's actually makes a lot of sense to me. I haven't worked directly hands-on with data for a long time, but what you've described fits with what I already understand from the final product of microdata sets that have been anonymized. But what I'm thinking about right now is how faculty or researchers are being asked to do so much with managing their research data. This sounds like yet another set of skills to add on. And I'm just wondering what your thoughts are about approaching faculty regarding this. Is it something that every faculty person should be doing? Is it something that librarians should be hopping on board and saying, we'll do that, or data service centers? I'm just wondering what you're thinking about adding this one more thing to the basket of things researchers need to do.
To be honest, I think this is a real mess, and it's a extremely unanswered problem when it comes to things like data sharing mandates for human subjects data. I don't think it's reasonable, especially given the current status of tools that are available for working with anonymized de-identifying data. I don't think it's reasonable to expect faculty members to hand de-identify their data sets to the point where they can reasonably shared. So that is why I suggest that for higher risk data sets that are not small samples, curators should consider recommending other methods of sharing data. I'm part of a working group under Portage that's coming up with a set of guidelines for de-identifying COVID data, or at least not so much guidelines as a help sheet that tries to explain some of these things. But really, I think it's asking too much. And I think that, yeah, it's asking too much of researchers. It's definitely asking too much of librarians to expect them to assure that data has been de-identified. And I think that really we need to step back and do a lot of thinking about how human subject data should be shared, given that there are all these problems associated with it. Right,
yeah. So it's really, it's a looming pain point for everybody.
Yes, that would be a good way of describing it.
Good, good. Okay, I'm glad to know I'm on the right page with this. So yeah, thanks. That's good.
Joyce, we have another question now from Krisha.
Yeah, hi. So just along those lines, I'm wondering at what point, like in the data collection process, does one need to kind of consider these? Like, I know that when people who are doing, surveys, particularly with individuals and on sensitive topics, that they need to go through their research ethics boards. And, there's often a statement or a waiver or some consent form that people will sign to consent to what's going to happen to their data. So is this something that has to be considered at that stage, where they're able to say, the researcher can then say, we're collecting this data, we're using it in this way, and it will be either destroyed or it will be an anonymous form of this data will persist. So I'm just wondering if there's a role there, or how that kind of setup has to happen before data is even collected.
I think there are a number of roles that the Research Ethics Board could play at that point, and that a number of things that should be considered at that point. I mean, first, the researcher should not be collecting quasi-identifiers that they don't need. It will make everyone's life easier in the long run if they're just not there at all to be dealt with. I think particularly for data sets that I identify as really high risk, which are the ones that are a large sample of a small population, they need to be very careful about what types of promises are being made. Don't promise that you will share anonymized data if there's no practical way of anonymizing the data. Consider asking for permission to just share data that is anonymized as well as possible. I think, actually, I can't really think of a good way of wording it, but I think it's an area that needs a lot of work, basically. Yeah. I'm sorry, is that at all helpful?
No, it is. It's certainly more to consider. It's the stage at which this, like, I kind of struggle sometimes. I'm a data manager with a group, like a large research group, and some people deal with these types of consent forms and just kind of defining. People want to know how their data is going to be managed, and so there are clearly questions that need to be answered early on, but again, maybe they can't be answered to the full extent, as you just mentioned. So, but lots of work. You're absolutely correct. Thank you.
I'm wondering if anyone here has any interesting experiences with data anonymization or any disasters to share.
If you have anything that you'd like to share, you can raise your hand and I'll unmute you.
Possibly the worst thing I ever encountered was a student I was working with emailed a particular department asking for some statistics on prisoners, and the department in question just emailed the person an access database and suggested that they calculate them themselves. And this database had things like the names and addresses of next of kin of the people in the data set. I'm not sure exactly what type of protocol could have prevented that, apart from really education. It was really quite stunning to me.
Oh my goodness.
This was in the US, if anyone's wondering.
Hi, Erin, you can go ahead.
Thanks. No, nothing specific, like no specific case to raise, but just to echo what Kristi was saying, that, you know, I think a lot of times researchers get to the end of a project and they're asked to share data, either by a journal or someone knows about their research and just wants to see the file. And so it's not malicious, but, you know, the data you're just checking off boxes in a way, and sharing data that were maybe not properly anonymized. And I don't know what the solution is. I think it is maybe trying to come up with better solutions for how they can archive that data, not in a public archive, you know, because I don't think there are a lot of those available right now. There aren't a lot of repositories that can provide restricted access for sensitive data. A lot of times a researcher doesn't have capacity to manage the data beyond the life of the project and the funding of the project. So yeah, but just to say that I like your idea, Kristi, of, you know, we need to start having these conversations about how we can support researchers and librarians in a way that they're not being supported now.
Yeah, I'm afraid my presentation may have possibly raised more problems than it solved, but I think it's important that people at least know that these issues exist.
Yeah, I got it.
Sorry, Kristi,
No.
did you have something to add?
Oh, yeah. Well, actually, I think that, you know, to your point, Kristi, I think that raising questions is where it all begins, right? As we unravel or develop ways to manage these things, the questions have to be asked first. I was just gonna, I went to a presentation at McMaster here, like it was StatsCan, and we have like a research data center here. And I think I was chatting with someone there about the possibility of them like taking on data that doesn't, like if there could be a role for them potentially to help manage data that doesn't originate with StatsCan, but to kind of utilize some of that expertise. And I mean, it was just a kind of offhand comment, but I'm wondering maybe there is a role for the people at RDC to manage data sets outside of the Stats Canada data, like if potentially a university could tap into some of that expertise and, you know, kind of on a contract basis or something like that, where they have the expertise in housing data and the many tools that are, I guess, proprietary in managing those data sets. It's
I think that would be a really excellent idea and an excellent use of those resources if Statistics Canada was interested in sharing. Even if they only wanted to provide more education on how to safely share anonymized data, I think that would be really helpful.
Yeah. I think some of it was like, and again, it was a while ago that I attended this, but I guess I sort of understand some, proprietary nature of some of their algorithms, because they could be, maybe they could be used to reverse engineer to get back to original data. But I like the ideas that they presented, and that you presented here, of, kind of like statistically representative data sets and things like that are, I mean, above my mathematical knowledge, but really help me to kind of think of data in a different way, and how you can balance the risk and the research reward of these data sets. So thanks.
Thank you.
Thank you. Any additional questions? Again, you can feel free to raise your hand and I'll unmute you. You can go ahead, Lucia.
Need to unmute her.
She should, Lucia, you should be able to unmute yourself now.
I'm always having problems with the unmute, sorry. Thank you, Kristi. That was a really informative presentation. I'm just thinking back with the stats can question I had about we know what type of data anonymization they use. And I'm wondering if maybe they're not making it available because maybe they don't want people to reverse engineer it. I don't know if that's the possibility.
That's quite possible. I don't know.
And I'm wondering about researchers themselves. Like, it'd be probably best practice for them to maybe talk about how they have made the data private and anonymized as well. But maybe they might not want to do that because of that reverse engineering possibility.
I think they could probably talk about them in general, talk in general terms. I actually think that, for example, one thing research ethics boards might want to do at some point is if someone says they're going to share anonymized data, the researcher sharing it should be required to explain what they mean by anonymized data. Are they just going to be removing direct identifiers? Do they have a plan for dealing with quasi-identifiers? Are they able to comment on their data being a small sample and of a large population and therefore safer? I think there needs to be more sharing rather than less. I think yeah, I'm of two minds of this. I can understand why Statistics Canada doesn't want to reveal the exact algorithms, but I think that puts us in a difficult position as to learning exactly what the best practices for doing this are.
Yeah, I agree with you. I think that there should be a lot more sharing going on out there. And I never thought of that angle of the Research Ethics Board, maybe putting in some guidelines on how to make your data private and anonymized. Thank you.
Thanks, Lucia. Krisha, did you have something to add?
Yeah.
Oh. Sorry, go ahead.
No, that was, I was just gonna see, I just saw this, this comment from Joyce Thompson in the notes about Compute Canada. I think that that's a really excellent point there. Just even in the storage of data, because I think that a lot of this, when it's identifiable data, just the storage of it is so important at that point even. And it, just the broad reach of Compute Canada, and I guess like the new Indrio, or I guess new is redundant there, but maybe there's a really a good opportunity for this to be brought to the surface a bit more for people. So thanks again.
I know that the Federated Research Data Repository, which is funded by Compute Canada, is currently developing working on a project for safe sharing of anonymous data, zero knowledge archiving, not so much sharing. But I'd like to see, it would be interesting if an extension on that could be built, possibly partnering with the Research Data Center Network or some other way of zero knowledge sharing of potentially sensitive data. But I think that's probably a ways off.
Yeah, the reason I mentioned it was because I attended a webinar with them this morning where they're starting to do reaching out to researchers in the humanities and social sciences to develop partnerships there, and they seemed terribly approachable at every stage of the research life cycle in terms of providing not only advice but you know, space and expertise and consultation. So it just makes sense that they could partner in interesting ways for particular sets of data that you wanted to. If you're putting it into a data portal, for example, they're very keen to be helping people create outward-facing portals that other people will then be able to use. So I think there's some potential there anyway.
Yeah, we'll just hope some of that potential gets acted on.
Yeah, I know. Oh, thanks very much. This has been great. Yeah.
Oh, thank you. Okay.
Being mindful of the time, one last call for any questions. Please feel free to add them into the chat or raise your hand and I can unmute you.
If there are no more questions, thanks everybody for listening.
Thank you, Kristi. All right, thank you everyone for joining us today. We will be sending out a survey and recording of today's webinar. Thank you for attending.